Hello, I'm Sienna Bowes. Welcome to my channel, Learning Balanced Life. Today we are going to talk about molecules formed through covalent bondings between nonmetal atoms. Let's take a look. The nonmetal for today is fluorine. Let's do a little analysis about fluorine and its EC. Fluorine, whose symbol is F, and atomic number is atomic number is 9. Its electronic configuration, or EC, is 2, 7. That means 2 electrons in the K shell and 7 in the L shell. In the K and L shell, the EC is 2, 7. Now, what is the main aim? What is the main motive of the reaction over here? Well, in these molecules, basically have to obtain the stable octet or duplet or octet configuration of the nearest inert gas to that specific nonmetal. Now, the configuration duplet or octet is completely dependent on the inert gas which it's near to, which the nonmetal is near to, the nearest inert gas. So now we will see how is the molecule formed here. Now, firstly, one diagram. Here fluorine has 7 valence electrons, so we have to make our drawing accordingly. Another ellipse with another fluorine. 2 on the top, 2 at the side, 2 at the bottom, and 1 which goes in sharing. And here also, the same way we'll draw 6 electrons, and 1 has gone for sharing. Here we are sharing electrons, and that is aimed at again achieving this stable configuration, which can either be duplet or octet, depending on the inert gas. Now, why are we sharing? In case of metals and nonmetals, the metal donates electrons and nonmetals gain electrons. That means they have a tendency to gain electrons, but here there is no donator from where they can gain, hence it is sharing of electrons. Sharing of electrons is aimed at achieving the stable octet EC, or electronic configuration, EC of the nearest inert gas is neon, Ne. Neon, Ne. Sharing of electrons is aimed at achieving the stable octet electronic configuration, or EC, of neon Ne. Here we are sharing 2 electrons in the overlapping center, and we know that 2 electrons is equal to 1 bond. We have to keep this in mind. So our next step will be like this. A single covalent bond is formed between the two fluorine atoms. Over here, there is one more very important thing to keep in mind, which is the covalency and electrovalency. Now, we know that fluorine has actually 7 valence electrons, so it has to gain one to achieve this stable octet or duplet, whatever. Here in this case, octet, because the nearest inert gas is neon, Ne. It has to achieve this electronic configuration, for which it has to gain 1 electron. So its electrovalency is 1. And from here, we can understand that its covalency, it means its valency in case of covalent bond formation, is also 1. So covalency and electrovalency are the same. So fluorine's electrovalency equal to 1 is equal to fluorine's covalency. This is a very important observation which is to be kept in mind. And finally, our product is the F2 molecule is formed. F2 molecule is formed, or we can write like this: fluorine molecule is formed. Let's do a short revision of what we learned. Sharing of electrons is aimed at achieving the stable octet electronic configuration of neon and E. 2 electrons is equal to 1 bond, so a single covalent bond is formed between the 2 fluorine atoms. Fluorine's electrovalency, which is 1, is equal to fluorine's covalency. And finally, actually here, the fluorine F2 molecule is formed, or we can write the fluorine molecule is formed. And about our short analysis, fluorine, whose symbol is F, has atomic number 9, and its electronic configuration, or EC, is 27, that means in the K and L shell. And the main goal of this reaction is to reach the stable duplet or octet configuration, which is totally dependent on the inert gas, which is nearest to the specific nonmetal atom. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.